Let's explore the graph of the sine function, y equals sine x. Here I've made a table where x is the angle in standard position and y is the value of the sine function. Notice that all the angles in my table are special angles, so you should be able to determine all these values on your own. Then I plotted all the ordered pairs, as you can see. So now let's see what the graph of sine x looks like. Let's connect our points. So we have a nice graph of the sine function. If I had chosen values bigger than 2 pi, say 2 pi plus pi over 6, that would be 13 pi over 6. The value of the sine function of 13 pi over 6 would be what? A half. Exactly. So you can see that this pattern is going to repeat itself if I had chosen values bigger than 2 pi or less than 2 pi. Now let's look at some characteristics of the sine function now that we know the graph. Here's the graph of y equals sine x. Let's look at some of the characteristics of the graph. The first thing we want to notice is what's the domain. Remember, domain means the values of x. Well, notice that the left side there's arrows, so it's going to negative infinity on the right, on the left, excuse me, and on the right it's going to positive infinity. So the domain would be all real numbers. Now let's look at the range of the function, the sine function. That's looking at the y values. What do you notice about the y values? Notice the smallest y value is -1. The largest y value is 1, and it takes on all values in between, so the range would be -1 to 1. Another thing we notice about this, there are 3 periods shown here. Here's one period, here's another period, and another period where the sine function is repeating itself 3 times. So that means the period of these intervals in between here, here's another period, and finally we have one more period drawn here. So the period for the sine function would be 2 pi. Now what that means is that if you're trying to find values, that means the sine of some value x is going to be the same thing as the sine of x plus 2 pi times, say, n, where n is any integer. They'll be the same value because the sine function is periodic. Now, another thing we notice about the graph is that its sine is an odd function. What does that mean? That means that the sine of negative x is the opposite of the sine of x. That also means the graph is symmetric about the origin. Another characteristic, let's look at the intercepts. What's the y-intercept? Where does the graph cross the y-axis? And we can see that the y-intercept is 0. Now, what about the x-intercepts? Well, there's an infinite number of them, as we can see, because remember this goes on forever. But let's describe where they occur. Well, let's see. One x-intercept is at 0, and then pi, and then 2 pi, and so on. Do you see the pattern? So the x-intercepts are at all multiples of pi. So we can describe that by just saying n pi, again, where n is an integer. Two more things we want to notice about the sine function. Notice that there's a maximum point and a minimum point, a relative max and a relative min. And we want to talk about where they occur. Well, we know there's an infinite number of them because the sine function repeats itself. Let's look at the relative max and talk about where they occur. The relative max occurs at what x values? Well, let's see. The first one occurs, well, not the first one, but one of them occurs at pi over 2. Where does the next one? Well, it's going to be a period away, 2 pi away. So I can describe where they occur by saying at x equal pi over 2 plus 2 pi n, where n is any integer. And then, of course, now we see there's the relative min. Where does it occur? The relative min occurs at what x value? Well, one of them is 3 pi over 2. And again, to get to the next one, we add multiples of the period. So we can say at 3 pi over 2 plus 2 pi n, again, where n is an integer. You should learn all these characteristics of the sine function. They're very important. Now we're going to focus on just one period of the sine function and look at some of those important points that you're going to need to know. Here's the graph of y equals sine x with x between 0 and 2 pi, or one period or cycle of the sine function. And we want to notice some important points on this cycle. Those important points occur at the x-intercepts and the y-intercept, which of course is the same in this case. So I've got the x-intercepts and then the points where the relative max and the relative min occur. Notice that these points occur at 1/4 of the period, so we call them quarter points. Let's list the quarter points. The first one is the origin, 0, 0. The next one is pi over 2, 1. Then pi, 0, 3 pi over 2, negative 1, and 2 pi, 0. These are important points for you to know, so you should know these quarter points for the sine function so that you can graph it easily. Let's explore the graph of the cosine function y equal cosine x. Here I've made a table of values where x is the angle in standard position in radians and y is the value of the sine function. Notice that all the angles in my table are special angles, so you should be able to get all these values on your own. Then I plotted the ordered pairs, as you can see here, so we can see what the graph of the cosine looks like. Let's connect our points. So let's see, it's going to start up at 1, go down, and do this. So I've plotted the points from 0 to 2 pi. What would happen if I chose values bigger than 2 pi or, say, less than 0? Let's take an angle. For example, 2 pi plus pi over 6 would be 13 pi over 6. What would the cosine of 13 pi over 6 be? Well, let's see, that's in quad 1. Cosine's positive, so it's going to be the square root of 3 over 2. So we can see that this pattern will just repeat itself for values bigger than 2 pi or less than 0. Now that we know what the graph of the cosine looks like, let's look at some characteristics of the graph. Let's look at the graph of the cosine function. Here I've got 3 periods of the cosine function, and we want to look at some of the characteristics. Well, the domain of the cosine function, the values of x, are all real numbers. We can see the graph goes from negative infinity to positive infinity, so the domain is all real numbers. The range will be the y values. Let's look at those. The y values go from negative 1 up to 1 and take in all values in between, so the range would be negative 1 to 1. The period is 2 pi. We can see here's a period between here, that it repeats itself again here, so here's another period of 2 pi, and then I see another period over here. So the period for the cosine function is 2 pi. Now let's look at some another characteristic, which would be, I noticed that this function is symmetric about the y-axis, which means it's an even function. That means that the cosine of negative x is the same as the cosine of x. It's symmetric about the y-axis. Next, let's look at the intercepts. Well, the y-intercept is what? The y-intercept is 1, crosses the y-axis at 1. What about the x-intercepts? Let's look at those. Where do they occur? Well, we can see we have an infinitely many of them. We can see 1, 2, 3, 4, 5, 6 here on these cycles here. But where do they occur? Well, let's see, pi over 2, then the next one's that, 3 pi over 2, 5 pi over 2, 7 pi over 2. Can you predict where the next one would be? 9 pi over 2, exactly. So you can see that they occur at odd multiples of pi over 2. How do we write that? Well, odd number is any number. 2n plus 1 gives you an odd number, and we multiply that odd number times pi over 2. That's where all the x-intercepts occur. The other thing we want to look at is the graph has relative max and relative min points, and we want to talk about where they occur. Let's look at the relative max first. Where does it occur? Well, this one's, of course, at x equals 0. And then the next one occurs 2 pi away, so we can add multiples of the period 2 pi, which is the same thing, of course, as saying 2 pi n, where n is any integer. Now let's look at the relative min. Here's a relative min. Where does it occur? At pi. Where does the next one occur? At the period away. This is an interval of 2 pi. So the relative min occurs at x equal, this would be pi plus 2 pi n, again, where n is an integer. So here are the characteristics of the cosine function that you should be very familiar with. Now I want to focus on just this one period and look at some important points. Here we have one cycle of the cosine curve, and we want to look at some important points. The important points are where the intercepts or the relative max, the x-intercepts, and the relative min. Those points occur at 1/4 of the period, so we call them quarter points. Let's list the quarter points for the cosine function between 0 and 2 pi. Well, the first one is at 0, 1. The next one occurs at pi over 2 is 0. The next point here is pi, -1. 3 pi over 2, 0, and finally 2 pi, 1. So here are the 5 quarter points for cosine x between 0 and 2 pi. You need to know these quarter points for the cosine function so you can graph it. Here we want to graph functions of the form y equal a sine x and y equal a cosine x to see what effect a has on the graph. First thing we need to talk about is the amplitude of these graphs will be the absolute value of a. It's always positive. Let's look at an example. So I have this function y equal 3 sine x. What's going to happen is this 3 is going to be multiplied by all these y coordinates of the quarter points. So you can see that I've got all those quarter points of sine x listed. So now let's figure out what the quarter points will be for 3 sine x. Well, it doesn't change the x coordinates, so they're still going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So to get the y coordinates for 3 sine x, we're going to multiply these values by 3. So 0 times 3 is, of course, 0. 1 times 3 is 3. 0 times 3 is 0. -1 times 3, -3. And then again, 0 times 3 is 0. So here will be the quarter points for y equal 3 sine x. Let's graph that function. So we have 0, 0. Then we have pi over 2, 3, pi 0, 3 pi over 2, negative 3, and 2 pi back up to 0. So the amplitude is this distance, half the distance between the max and the min value. So let's write the amplitude for y equal 3 sine x. The amplitude will be the absolute value of 3, which is 3. Again, that's the distance, half the distance between the relative max and the relative min, which makes the range of this graph what? Exactly. The range is now going to be negative 3 to 3. Now let's look at another example. Let's look at the graph of y equal negative 2 cosine x. The amplitude will be the absolute value of negative 2, which of course is positive 2. Now, in order to graph this function, what we're going to do is multiply negative 2 by our y coordinates of our quarter points for y equal cosine x. So let's write the quarter points for y equal negative 2 cosine x. Well, the a only affects the y coordinates, so the x coordinates will not change. Okay, so let's look at the first one. So the y coordinate of cosine x is 1, multiply by negative 2, and what do you get? Negative 2. It's important to note that you don't multiply your y coordinates by the amplitude, you multiply your y coordinates by a. Alright, so let's keep going. 0 times negative 2 is still 0. Negative 1 times negative 2 is positive 2. 0 times negative 2 is 0. And 1 times negative 2 is negative 2. So here are our quarter points for y equal negative 2 cosine x. Let's graph this function. So let's see, I have 0, negative 2, and pi over 2, 0, pi 2, 3 pi over 2, 0, 2 pi, negative 2. So here's the graph of y equal negative 2 cosine x. What is the range for this graph? Well, the range is going to be negative 2 to positive 2. So in general, when you're graphing functions y equal a sine x or y equal a cosine x, the amplitude will always be the absolute value of a, and the range will always be negative absolute value of a to positive a. Here we want to look at graphing functions of the form y equals sine bx and y equal cosine bx. For these functions, the period will be 2 pi divided by b. Now it's important to note that b must be positive here. Let's look at an example. Y equal cosine 3x. So b is positive 3, so the period's going to be 2 pi divided by 3. So b is going to change the x coordinates. Here I've listed the quarter points for y equal cosine x, which of course has a period of 2 pi. For cosine 3x, the period is 2 pi over 3. The quarter points occur at 1/4 of the period, so let's figure out what is 1/4 of this period. 1/4 of 2 pi over 3 is pi over 6. So now our x coordinates are going to be in increments of pi over 6. The y coordinates will stay the same. So let's list the quarter points for y equal cosine 3x. Okay, so the first one still occurs at 0. The next quarter point is going to be pi over 6 increments, so you're always adding pi over 6 to each x coordinate to get the next one. What is pi over 6 plus pi over 6? Well, it's 2 pi over 6, but of course you always reduce your answers. Okay, and then 2 pi over 6 or pi over 3 plus pi over 6 gives you 3 pi over 6, which is pi over 2. And finally, 3 pi over 6 plus another pi over 6 is 4 pi over 6, or the period of 2 pi over 3. So here are the quarter points for y equal cosine 3x. Let's plot those points. So we have a period of 2 pi over 3. And let's see. Notice the y coordinates are going to be 1 and negative 1. So let's see. The first point we want to plot is 0, 1. Then the next point, quarter point, is pi over 6, 0. Pi over 3, negative 1. Pi over 2, 0. And 2 pi over 3, positive 1. So here's one period for y equal cosine 3x. What is its amplitude? Well, we can see that it's still 1. Whoops. Notice that in this case a is 1, so the amplitude is 1. What is the range? Well, it's negative 1 up to positive 1. Let's look at graphing functions of the form y equal a sine bx and y equal a cosine bx. The amplitude of these functions will be the absolute value of a. The period will be 2 pi over b, again for b positive. Let's look at this example, y equals sine negative pi x. Right off the bat, we notice that our b is negative, so what do? Well, we have to remember something about the sine function, and that is that the sine is odd, and that means that the sine of negative x is the opposite of the sine of x, so we can rewrite this function as negative sine of pi x. Now we can find our amplitude, which will be the absolute value of negative 1, which is 1. And our period for this function will be 2 pi divided by pi, which is 2. Now we want to get the quarter points for this function. We need to get 1/4 of the period to figure out the interval between the quarter points, which will be a half. So we're going to be adding a half to each of our x coordinates to get the x coordinates for y equal negative sine pi x. The first x coordinate will stay 0. Now what do? Let's just do the x coordinates first, and then we'll come back and do the y coordinates. So what we want to do is we want to add 1/2 to each of these x coordinates. So 0 plus a half is a half. 1/2 plus a half is 1. 1 plus a half is 3/2. And then 3/2 plus another half gives you 2. So that's our x coordinates for our quarter points. Now how do we get the y coordinates? Remember, the y coordinates are affected by a, so we want to be multiplying these y coordinates by a, which in this case is negative 1. So we're going to multiply each of these y coordinates by negative 1. So let's see, we're going to get 0. 1 times negative 1 is negative 1. 0 times negative 1 is 0. Negative 1 times negative 1, positive 1. And then 0 times negative 1 is 0. So here are our quarter points for y equal negative sine pi x. Let's graph that function. Okay, so let's see, we have 0, 0. Then we have a half negative, oops, not pi over 2. Should have been a half. So all of these should be a half, 1, 3 halves, and 2. So this point, 1 half negative 1 down here, 1 half 0, 1 0, 3 halves positive 1, and then 2 0. So here would be 1 period for the function y equal negative sine pi x. Notice that it's going down first. There's the negative, which reflects it about the x-axis. What's the amplitude? We said was 1. What's the range for this function? Let's write that down. The range would be negative 1 to positive 1. Let's take a look at graphing y equal negative 2 cosine of negative 4x. Again, the first thing I need to notice is when b is negative. To find the period, you need a positive b. So we need to rewrite this function. Remember that the cosine is even. Let's see. What does that mean? It means that the cosine of negative x is the same as the cosine of x, which means the cosine of negative 4x is the same as the cosine of 4x. So this can be rewritten as y equal negative 2 cosine of 4x. Now, what's the amplitude? Well, the amplitude is going to be the absolute value of negative 2, which of course is positive 2. What's the period? Well, we find the period by taking 2 pi, dividing by b, which in this case is 4. So our period will be pi over 2. Now, how do we get our x-coordinates? We need to know the 1/4 of the period. And what is 1/4 of pi over 2? Well, that's pi over 8. So pi over 8 is going to be what we add to each x-coordinate to get our x-coordinates for our quarter points for this function. So let's write those down. So let's say we have negative 2 cosine 4x. The first x-coordinate will stay 0. Now, what do we add to 0 to get to the next one? You add pi 8. So this next x-coordinate will be pi over 8. So again, you're adding pi over 8 to each x-coordinate. What's this x-coordinate going to be? Well, what is pi over 8 plus pi over 8? Well, that's 2 pi over 8, which you reduce to pi over 4. And then keep adding pi over 8. That's 2 pi over 8 plus pi over 8 gives you 3 pi over 8. And then 3 pi over 8 plus another pi over 8 gives you 4 pi over 8, which of course is pi over 2. So those are our x-coordinates for our quarter points. How do we get our y-coordinates? Well, we need to multiply each of these y-coordinates by a, which is negative 2. Make sure you don't multiply by 2. It's always a, not the amplitude. So let's see, what is 1 times negative 2? Negative 2. 0 times negative 2 is 0. Negative 1 times negative 2 is a positive 2. 0 times negative 2 is 0, and 1 times negative 2, negative 2. So here are our quarter points for y equal negative 2 cosine 4x. Let's look at that graph. So we have 0, negative 2, pi over 8, 0, pi over 2, positive 2, 3 pi over 8, 0, and pi over 2, negative 2. So here would be 1 period for this function y equal negative 2 cosine 4x. We figured out the amplitude for this function was 2. What's the range for this function? Well, the range is going to be negative 2 to 2. Remember, it's always negative absolute value of A to positive absolute value of A. In this example, we're given a graph and we want to determine the equation of a function of the form y equal a sine bx or y equal a cosine bx. So we have to decide whether we're going to use a sine function or a cosine function. Well, how do we know? Let's look at the first quarter point. It's 0, 0. It goes through the origin, so we know we're going to use a sine function. So we're going to write y equal a sine bx. So now we have to find b and a. Well, remember, b is with the period, so let's look at this graph. What's the period for this graph? We can see the period is 8 pi. So let's write that down. And how do we get the period? Do you remember? That's right, you take 2 pi and you divide by b to get the period. So we can solve for b, multiply both sides by b. So we get 2 pi divided by 8 pi, which is 1/4. So now we know b is 1/4. Now we need to find a. Well, I can see from the graph that the amplitude is 2, but that doesn't mean that a is 2. Notice that this graph is decreasing first. This y-coordinate of this quarter point is negative 2. So I know a is negative 2. So now what's our sine function? Y equals negative 2 sine of 1/4 times x. You need to practice working these examples until you've mastered the skills and concepts involved.